Do all El Niños look the same? That's the kind of question. I implied already that the warming doesn't always happen all the way in the east. More recently, in the last 2 decades, let's say, there's been a lot of debate that is related to whether there are different flavors of El Nino. Okay, so this is also referred to now as ENSO diversity, or different flavors of El Nino. This is the classical El Nino we talked about, where the warming is happening in the eastern tropical Pacific and along the South American coast, and cooling is happening on the western side with this butterfly wing type of structure, which is related to ocean waves, which we haven't discussed. And this is the perturbation we talked about, where you have anomalous westerlies in place of the traditional northeasterlies and southeasterlies, the trade winds, and you have anomalous rising branch of the Walker cell here, and a anomalous sinking over the West Pacific with excess rain and so on this side, reduced upwelling, warm SSTs, and dry droughts and dust storms on this side. So at some point, people had noted already in the past, more than 40 years ago, that sometimes the El Nino doesn't warm all the way to the east, but it kind of remains in the central western Pacific. So the West Pacific convection still moves eastward. You can see that the Walker cell has now split into two instead of this one anomalous Walker cell. The divergence and deep convection has moved to the central equatorial Pacific, and there is a Walker circulation here, and there is a Walker circulation there. So you still have droughts on this side, but this region is essentially cold still. Okay, this is called the Central Pacific El Nino, or the dateline El Nino, and still relates to some fundamental processes like the displacement of the West Pacific convection, which seems to be the main driver. And there are papers arguing that the subsurface processes of accumulation of the warm water and its discharge are essentially the same in all these flavors of El Nino. Okay, because this also has two flavors where the warming is more strong off away from the coast, but during the so-called extreme El Ninos of like 82, 83, 97, 98, and 2015 and 2016, the warming is much stronger, but also much more spread along the South American coast. So those are called extreme El Nino. As opposed to this, the La Nina tends to have only one flavor. It always cools in the eastern central Pacific. It doesn't do much along the coast. Okay, so these are questions that are not fully answered. Obviously, you are beginning to get a sense that so much remains unknown about El Nino, and you would be right, which is a good way to think that there is a lot of research to be done and a lot of discoveries to be done as well. So you still have a chance to contribute something amazing to El Nino. The other question is, we mentioned ENSO variability. How does El Nino change? Especially because we are interested in how El Nino may change with global warming. I will have more details on the next podcast, but here is nice data of ENSO events per 100 years from basically over the Holocene period, where the last ice age ended, and then we have these temperatures shown as petrological tracers. So I won't go into that, but there are Holocene climatic optimum kind of period, neoglacial period. All these are kind of geological terminologies for petrological tracers, but we will see later on that there was variability of global temperature of order 1 degree, which we already mentioned in a previous podcast, but we'll go into a little bit more details in the coming podcasts in this chapter. So this shows that there are variations in the number of El Niños per century over the Holocene period. Okay, again, there are debates about whether this is accurate because these are proxies. They take the evidence of El Niño impacts in some place and then they try to count El Niños based on that. They are not direct measurements of El Niño and they don't necessarily come from the East Pacific and so on. So there are some other evidences collected from corals, for example. We said corals are affected by El Niño. Second, corals give us evidence of how El Niños have changed, and there are some papers by people like Kim Cobb, who is a very famous coral scientist from Georgia Tech, arguing that there is no strong evidence of changes in El Niño behavior over the Holocene. So this debate continues as well. But this sets us up for looking at what would be the role of global warming on El Niño. And why should we care? Why do we care about how El Niño changes with global warming? It turns out that what happens in the tropical Pacific does affect how much heat goes into the ocean, and that modulates the global warming. So we should care about how the East Pacific responds to global warming. So it's not just El Niño, but it is the East Pacific itself responding to El Niño. So we'll look at that in a little bit more detail in the next podcast. Again, lots of open questions, but all centered around the physics that we know fairly well.